Hello everyone, welcome to this session. My name is Stan Givinji. I'll be taking through the cryptographic algorithms, and if you have checked in our previous videos, we have posted something on OSI security model. It's very important that you have a look at that video so that you can be able to understand why we use different cryptographic algorithms. So in this session, we also explore the application areas of identified cryptographic algorithms and more so see when the best time to use which algorithm to achieve what service. So ideally, cryptography is a way of protecting data from prying eyes of learners of the power of algorithms. So you want to ensure that you're providing the encryption of the plain text of your data before transmitting, and also if you have data at rest, you're also implementing those cryptographic algorithms to secure your data at rest. So we always say that cryptography is a primary goal is to conceal information using mathematical concepts, and these algorithms provide users with a secure digital communication system that guarantees confidentiality, integrity, and authentication. And these are part of the CIA model. And in addition to that, we say that you also want to achieve the aspect of non-repudiation, and where someone doesn't deny having sent or received data. So in actually saying the digital realm, encryption are the core of the modern cryptography. So we deal with the encryption where you're converting the plain text to ciphertext to ensure that it is intended receiver can access that information. So what it means by it's a ciphertext is information that is not really intelligible. Yes, you can see there's data there, but now you can't make sense out of that data. So the encryptions is using process works with the encryption keys, and then decryptions use the decryption functions to decrypt data. So the process can also be referred to as, this process is also referred to as encipherment, where the opposite of it is also referred to as a decipherment. In some instances, you refer to it being referred to as encoding, and another aspect be referred to as decoding. So cryptography features, I think this is what we mentioned about the OSI architecture. So we're dealing with the security attacks, we're dealing with the security mechanisms, and also we're dealing with security services. So cryptography features is that you want to ensure confidentiality. So you want to keep secrets safe. Control is that the core cryptography ensuring that data can only be accessed without authorization. So that data can only be accessible by the person who is authorized to access that data. In regards to integrity, we see that these are ensuring that there's no insertion, there's no deletion, there's no modification of data. So you have to preserve data accuracy. So it's a central aspect of cryptography to ensure the accuracy, consistency of data, that the data sent is exactly the data received. So we use algorithms like hash functions to ensure that you achieve the data integrity. Authentication on the other side is you want to verify the identity. So authentication is a vital aspect of cryptography that serves to ensure that they identify the parties involved in the communications. So you have the peer entity authentication, where the data is coming from, between the nodes, and the data origin, where you're dealing with the node that is sending data. So you want to also authenticate that node. Non-repudiations is another security service whereby you want to ensure accountability, so that no one deny having sent data, no one deny having received data. It's an essential aspect of cryptography that ensure that messages sender cannot later claim that they never participated in that communications. So these are the main cryptographic features that are actually implemented using various security mechanisms, and that's what referred to as encipherment. Some of the techniques used to be used across of these, we have said that in like integrity, you have to ensure that you're hashing, and in actual sense, the implementation of something like digital signatures can help someone achieve integrity, authentication, and non-repudiation at the same time. So there are some mechanisms that you implement that can be used to achieve one or more of these security cryptographic features. So we have three main cryptographic algorithms. The classification of these algorithms works together to protect the digital informations. We already acknowledge that the various forms of use is essentially appreciating it is that the role of protecting our lives. Ideally, these three main cryptographic algorithms, mainly the symmetric cryptography, asymmetric, and hash functions are the building blocks of ensuring that you achieve those security services. So symmetric cryptography is an algorithm or a technique that uses the same key to encrypt the same key to decrypt. So this key is usually shared using a PKC algorithm and is usually referred to as a session key, because the set of information is going to encrypt that data using a session key, and the retriever of that is going to decrypt a digital envelope to decrypt that session key so that I can be able to read that message. So some SKC ciphers are usually in either block cipher or stream cipher, and these mean that you have to define the mode of operation, because some of these algorithms operate in the stream cipher if you're dealing with the voice encryption, block cipher if you're doing the encryption of files. Some of these SKC algorithms, they are measured based on the strength of performance in regards to the size of the key. The larger the key size, the stronger the algorithm. The smaller the key size, the weaker the algorithm. So asymmetric on the other side is what referred to as a PKC algorithm. This is a cryptographic algorithm that uses a different key to encrypt and different key to decrypt. These keys are different, but they're mathematically related. So it means that the generations of the public key is also dependent on some parameters that were used to generate the private key. So because you use the public key to encrypt and also use a private key to decrypt, the public key is also used to verify the signature, whereas the private key is on the other side is also used to sign the message so that you don't deny having sent that message. Hash function, this is a one-way function, also referred to as one-way function. So that you don't expect to decrypt to reverse back. So the hash is, you want to have a message, you want to create a hash value out of it, and I'll be able to show you some of those models that we'll be able to show you in the next lab, or I'll be able to show you some of these SKC algorithm and also some of these asymmetric key cryptographic algorithms, some of the key hash function algorithms. So every time you create a hash, that hash, if you edit that message, it results to a different hash value, and we'll be able to show you some of those things in our next lab. So those are the three categories of our three cryptographic system. We're using the SKC, secret key cryptography, public key cryptography, and also the hash function. So this is a symmetric key cryptography. I think I mentioned that the setter is using that and is able to encrypt that data by using the shared session key. So these are the same key for encrypting, the same key for decrypting, and the receiver uses the private key to decrypt this so that it can be able to generate the session key. So some of the common cryptographic algorithms that's based on SKCs are things like the AES. The AES is one of the best algorithms that you can use to ensure that you achieve confidentiality. It's provide you the technique where you can be able to use the change size of the key. It makes use of the key 128. The flexibility of it can have a key of 182. There's a key of 256. So the AES in regards to these is that in addition to that, the others like 3DES, RCID, Profish, and TrueFish. So the idea is about ensuring that you encrypt your data. So these are going to use different keys. They have various input of data, because some use 128 bits as input data, so others use 64 bits as input data. But I have said that the larger the key size, the stronger the algorithm. Some main application areas where we use this is in secure transmission of data to the VPNs, when doing emails, name them, all those categories we want to share data, or you want to ensure that your information is encrypted. So it's always good to ensure that you use at least one of these as a symmetric cryptographic algorithm. The symmetric, we say this is a PKC algorithm. It provides secure communication using two distinct keys. So the asymmetric cryptography relies on two distinct keys, that is a public key and a private key. And we say that we use the public key to encrypt and the private key to decrypt. But we have said these keys are different, but they're mathematically related. The public key is also used to verify the signature. When someone sends you the data using the private, you can do to verify using the public key. And also someone is sending you data, they sign the message using their private key so that they create a digital signature to the message. That ensures that no one can be able to deny having sent that message, and one can deny having received that message. So asymmetric is more trying to achieve the aspect of confidentiality because it is used to encrypt session key. And also we say that it's also used to ensure aspect of non-repetition, to not having sent or received the information. We also say that it also uses an authenticator if you implement a digital signature in a communication. Some of the key application areas, we have seen it in many areas like email security, web security, and other encryption systems require key exchange over the public network. So combination of SKC and PKC enables you to achieve confidentiality, it enables to achieve non-repudiation, it enables to achieve authentication. So you have covered quite a number of security services in regards to those two cryptographic algorithms. The third one is a hash function. We say this is a one-way function. So hash function is a mathematical function that converts numerical input values into arbitrary length output that is a fixed length. So if you edit this message, then it results to a different hash value. So some of the main security service that we want to achieve is that the integrity, and we'll say that if you use it together with a digital signature, it can be used as an authenticator. Some of the algorithms that we have are things like MD5, SHA-1, SHA-2, SHA-3. SHA-2 is the most commonly used as a group of family of algorithms. We have SHA-2 128, SHA-2 256, SHA-2 512, and 584. So those are quite a number of quite an array of hash functions that are used. And this one is mainly used in password storage, data integrity checks, and also we mainly use them, especially in dealing with the aspect of a blockchain, maintaining file integrity, getting to know who's communicating who in network. So we mainly use these hash functions to do the verifications and also to combine in the creation of digital signature so that it can be used in combination with the PKC algorithm to achieve non-repudiation, to achieve authentications by verifications of by comparing the digest. If it is the same, that means that the message is not altered. So this is what you have here. You can see every time you have an input message, you hash, you create a digest. So if there's alteration of that, it results to a different digest, which means that you're able to know that an information is edited or not. A hybrid crypto system is important because you want to achieve all the security services. So this is a mode of encryption that merges two or more encryption systems, whether you combine SKC and PKC, or whether you combine hash function with PKC. So the idea is that you want to achieve those cryptographic features as much as you can, because those security cryptographic features are the ones that help you to prevent against the passive and active attacks. So in this example, we are seeing that we have the sender of information and the recipient of information. So they both generate the public and private key. So that is mean that's a PKC algorithm. You set the public key on the other side, and then you encrypt that with you encrypt the message using the SKC algorithm. It could be an AES. So the sender private key, set the private key, then you can be able to use the receiver is going to use their own private key to decrypt that message and be able to generate that session key, so they can actually be able to read that message. And that's what we refer to as a digital envelope. And that's a combination of at least two hybrid crypto systems. You're combining an SKC algorithm and also a PKC algorithm. So deploying enterprise scale cryptography, it means that these are some of the best practices that are used, meaning that you have to you have to adopt the best cryptographic algorithm. You have to overcome this challenge by organizing the need of strategies that combine the right skills, how the governance aspect, and a sound operating model, so that credential or technical solution that you'll be using. So it means that you have to use the longest supportable keys, because the cryptography, the strength of it is based on the strength of the key. Use appropriate encryption algorithm, learn the encryption environment. You also need to ensure that you secure centralized key management, how you're going to host those private keys and how the sharing of the public keys. So encryption should also happen in different layers, because you talk about the OSI layers. So then think about the secure web applications, how you can be able to ensure that these encryption processes happens at each and every security layer, especially at the application level, so you can mitigate those attacks. Thank you for listening to us in regards to that lab on cryptographic algorithms. We have been able to highlight some of the 3 cryptographic algorithms and when is the best time to use them. So in our next lab, we're able to show you how some examples of SKC algorithms, some examples of PKC algorithm, and also some examples of hash function to show you how you generate and how they're generated. Thank you, and thank you for joining this channel.